Hi, I'm Donald McIntyre, founder of Etherplan, and this is the Ethereum Classic podcast. And the guest today is Alex Tsankov. Hi, Alex. How are you?
I'm doing well. Nice to be chatting with you, Donald.
Thank you very much for doing this. You are leading the SHA-3 Classic Coalition, and I wanted to talk about that. But before that, can you tell me about your background?
Yeah, so my background is that I studied in university computer science and philosophy. So I was always very interested in this sort of intersection between technology and how people live and how we form societies. And that always led me to naturally to cryptocurrency. And I've been in the space as an enthusiast since 2012. That was when I first started playing around with it. But I didn't get serious and actually start working in it professionally until 2017, where I started working for a Bitcoin exchange in New York called Paxos. And that was how I learned all about doing cold storage and running an exchange, order books, orders, all of that, and learning kind of how does a marketplace actually function. And then from there, I got interested in DeFi and this notion of building financial instruments on smart contracts. And I was always an Ethereum enthusiast. And I never really thought very much about Ethereum Classic. But it hit me one day when I sort of was playing around with a lot of these DeFi apps that if the apps truly were to achieve global scale, there would be the users of them would need to be assured that it couldn't be rolled back ever. And there was always something that rubbed me the wrong way about the DAO. So I got very interested in Ethereum Classic. I got so interested, in fact, that I actually, in 2018, I created a smart contract on there called Commonwealth. And the idea is it's currently still the largest smart contract by account balance on
Mm-hmm.
the ETC chain. And the idea was this, it was going to be a global social security. And the notion is that people could come in and participate, and we were doing and create a currency along with it. And we were doing very well. We were growing quite a bit. And then in around 2019, the 51% attacks started
Yeah,
happening.
in January of 2019. Mm-hmm.
Yes, that was the first 51% attack. And that really got me thinking about questions like the nature of proof of work and how do we create a safe system that can continually reach consensus. And what I d- and that's sort of where I led me to
And
ECIP.
and now you're working full time on ETC and the SHA-3 Classic Coalition. Are you doing something else, and you're doing this voluntarily?
Yeah, so I do not work on it full time. I'm currently a site reliability engineer at Bloomberg.
Mm-hmm.
So we maintain huge data centers, and I work on the deployment systems that allow users to deploy their code to those data centers. But I've always worked on ETC because I love open source. I like the idea of collaborating on this system that can make the world a far better place, in my opinion.
Yeah.
So
Uh,
I
it,
still stick
Ether,
with it.
I'm Etherplan, and me. We are also volunteers in Ethereum Classic. I think that Ethereum Classic has a huge, enormous potential. So I think it's
Yeah.
very worth it. Let's talk about the 51% attacks in 2019 and what motivated. What was the background for you to start working on SHA-3?
Absolutely. So, to give the audience a sense of kind of a quick overview of the history of ETC. So, Ethereum was one chain up until 2016. Was that the
Mhm.
right year?
Yes.
2016. And then there was a huge DAO contract, a smart contract that ended up getting 10% of the funds in Ethereum Classic in one smart contract. And that got hacked, and the community split in two. The majority of the community wanted to roll that back to give the money back to the initial investors. And a small minority of the community, which eventually became Ethereum Classic, were users who believed that the code should only go forward, that you should not be able to roll back and do a bailout in a sense. And that organically became Ethereum Classic. Now, one thing that happened when you split was that ETC adopted the same hashing algorithm, the same mining algorithm as Ethereum.
Hmm.
And that algorithm is called ETH
Yeah.
so what happened is that when they split, they were around the same market value, and they both had the same algorithm. So it really wasn't an issue. But then what happened is as Ethereum started growing faster than ETC did, the amount of hashing power that was devoted to ETH as opposed to ETC ended up growing 10 times, 20 times, 30 times bigger. And one of the interesting properties of these hashing algorithms is that if you have the same miner base between them, a small group of miners from ETH can go and attack ETC and perform a 51% attack. So that's where they send a transaction and then they mine a secret chain in the back and then reverse back and then take their money back, kind of like writing a bounce check. So this was not really an issue for ETC at the beginning, but as they started growing, this became more of a problem. And it was always sort of a theoretical thing. So I had known in the back of my mind that there was always a risk of a 51% attack, but my suspicions were confirmed and the whole community learned in 2019, right when ETC was doing a huge uptrend in price. I remember it was going from, it went from $9 to like $15. And the miners on ETH must have been a little bit frightened by that or intimidated by that. So they took a portion of their hashing power and they rolled back 3,000 blocks on ETC. And it was absolutely terrifying when it happened because I've never seen a 51% attack before. I didn't know how to respond to it. But what effectively happened is I was working on my startup full time, and a lot of the services, so exchanges, wallets, all of those things broke or dropped support for ETC when the 51% attack occurred. And I think it's just important for the audience to know that a 51% attack is not a catastrophic failure of the chain. It is similar to like a denial of service on a large company. So when Google, let's say, has an outage for like 2 hours or 3 hours, that's similar to what a 51% attack is. No user's funds were actually cracked or stolen. Just the chain became unpredictable to use at that time. So that was the background. And within a few days, I sort of had my suspicions about the issue of having the same hashing algorithm as ETH. And I proposed that let's switch algorithms to a fantastic one that is used everywhere else in ETC and ETH, which is called Keccak 256. And it was just simply it was the one that I knew the most because my background is more smart contract development and not really nodes. And when you're working on smart contracts and writing in Solidity, you only have access to one hashing function, which is Keccak 256.
Okay.
Also in SHA-3.
Okay, that's what I wanted to clarify. So Keccak 256 is also called SHA-3, or one is within the family of the other. So when we talk about SHA-3 or Keccak 256, we're talking about the same algorithm. So in summary, then there's two chains. One is very big, which is Ethereum. The other one is smaller, which is Ethereum Classic. They both have the same proof of work hashing algorithm, and there's a way of attacking chains which is called reorg attack or 51% attack, which is basically that someone that has a lot of computing power could build parallel blocks to the blockchain and suddenly send them to the blockchain and change some transactions, disrupting, sometimes stealing funds from specific targets or victims, but it doesn't change the property agreements and accounts and balances of the network in general. It's just a specific targeted attack, and it doesn't, like you said before, it doesn't mean that the protocol or the network was hacked. It's just a reorganization of the blocks of or the ledger.
And actually, I would venture to say that a 51% attack is proof that the system is decentralized, because it means that another entity can come in with more hash power, and then if they reset history back to when they've acquired the majority of that hash power, which is very nuanced. But you can imagine sort of futures in which if there was, let's say, a theft, imagine someone steals hundreds of millions of dollars of cryptocurrency. If someone contacts the miners or is able to work or something like that, and is able to reach 51% of the hash power at a certain point, they can be able to, in a sense, reverse a certain transaction. But they would, but it's non-deterministic. It's not like you can call up on a phone call and be like, oh, change this. No, it needs to have mathematically more hash power than the rest of the network. And that to me is just a fascinating feature.
Yeah, whoever wants to reorganize the chain needs to have 50% or more of the hashing power of the whole chain. That's why big networks like Bitcoin and Ethereum haven't been reorganized, because they have these huge computing bases, global computing bases. So it's very difficult to gather that amount of computing power and reorganizing those chains. But smaller chains like ETC and others that have been victims of reorganizations are easier. And in the case of Ethereum Classic, this issue that the big chain Ethereum has the same hashing power as ETC makes it very easy for miners who are already mining Ethereum to just get together and go and attack the smaller chain, and it's easier for them. So that's I guess that's your base philosophy about changing the algorithm
exactly
to SHA-3, which positions ETC in a unique algorithm, and ETC would be the big one in that one specifically, no?
Exactly. So there were two parts to my reasoning. So the first part was that we just need to use a different algorithm than ETH. That was the first step. But then the second step was, okay, well, which algorithm do we use? And actually, Keccak 256 turns out to be one of the best, if not currently the best hashing algorithm available in the world today. And the reason why that is because it was created in 2012. Or it started in 2008, but it kept getting tested, and then in 2015 it was given the official designation SHA-3 by the NIST Institute of Science. And the notion is that if other hashing algorithms like SHA-2 were to be broken, then all of these users of software, planes, operating systems, encryption, cryptography, etc., they need a place to go. And SHA-3 was invented for that very purpose. And another interesting thing about SHA-3 was that there's no other blockchain that actually uses it as a proof of work algorithm. So if ETC were to switch to it, it would immediately become the largest in that space.
Okay.
So, yeah.
So to clarify, Bitcoin uses SHA-2, which is highly secure as well. If not Bitcoin wouldn't be so big and secure. But ETC would use SHA-3 to have this unique niche as well. Not only because it's a good algorithm by itself, but also to have this unique niche. So what is the goal?
If the only reason why I think Bitcoin uses SHA-2 is just because that was the highest tech at the time.
12 years ago.
So it was 12 years ago. Yeah, we have to remember that this was a long time ago. And Satoshi probably looked and said, what is the best hashing algorithm available right now? And then Satoshi just selected the best one. And ETC on the other hand, we should follow the same process. And we should just simply say, what is the best hashing algorithm available today? And that's SHA-3 beyond a doubt. So I think it's pretty clear that that's the good one to adopt.
Very good. So we understand in the background the differences between Ethereum and Ethereum Classic. What is the rationale for you proposing SHA-3? Can you tell me what is the SHA-3 Classic Coalition specifically? What are you doing now? Can you tell me about that?
So yes, so maybe we should give a little bit of background. Do you want to talk about like the three entities in this space and kind of how that works? And then I'll talk about how the SHA-3 Coalition fits into that.
Okay,
well, sort of
Yeah, bueno, that was a question that I had is, what is, in this effort to migrate Ethereum Classic to SHA-3, what is the position of the other main like client developers, client maintainers in ETC? No, you have Ethereum Classic Cooperative. They are maintaining one of the node clients, which is called Hyperledger Besu, and then you have IOHK. They are the main technological supporters of Cardano, and they have a team building and maintaining another node client for ETC called Mantis, and then you have ETC Labs, who are maintaining another one called Core Geth that has a higher share in the network. So those three teams, what do you see is their position regarding this change to SHA-3?
Yes. So that, yeah, and that's fantastic background for anyone that hasn't been following ETC for a while, because those are the three big entities in the space. So the idea is that we have a Telegram room that we created called the SHA-3 Classic Coalition. And it's a public room, and it's designed for the node client teams to come together in a space and to work together to actually be able to implement ECIP 1049, and to also bring in electrical engineers and chip designers into the same space as well, so that they can work on coming up with high performance implementations of this. And currently our plan is, so of the three entities, the most supportive one right now, and that I'm working the closest with, and the coalition is connected the most with, is the ETC Cooperative, working with Hyperledger Besu. And it's a really interesting, the ETC Co-op is fantastic as a patron in this space, because they are directly funded by ETCG, which is the publicly traded Ethereum Classic instrument. So 2% of all of the fees that get generated by ETCG get donated to the ETC Co-op. And then they spend that money to employ node developers and to help support the work of the community. So what we're doing is we're working right now, the PR is currently live, the pull request to Hyperledger Besu to implement this feature. It's currently live right now, and we are in the beginning stages of launching a testnet. So once we have a working testnet in which, and when I say that we're currently in the stages of starting it, we already have the client with the mining ready to go. It's creating blocks. We're basically have a very good understanding of what exactly it's going to look like when we switch over.
Good.
And we're going to create this testnet, ideally within the next few weeks. And the idea is that the other client teams, so IOHK and ETC Labs, can then just join the testnet and can optimize their miner around what works in the testnet. And then once we get all of the entities to be able to communicate with each other in the testnet, then we're able to actually go to the official proposal and say, on this block, we're going to activate. And then once we achieve that, we'll all have the patched clients. We'll then go to the exchanges, the wallets, the dApps in the space, and we'll say, are the mining pools, and they'll run the new software. And then on a particular date, ETC will now be using the SHA-3 proof of work algorithm as its primary.
So the mission or the goal of the SHA-3 Classic Coalition then is, first they're integrating it into one node client, then they're gonna create a testnet, and hopefully the other two client teams are going to also test their clients with that testnet. That means that they should reconfigure their clients or integrate SHA-3. And then after a while of testing and doing all the process of security checks, etc., the idea would be to set a future block for a hard fork, and then contact all exchanges and node operators to migrate to this new mining algorithm. But my question is, what is the sentiment? What do you think is the support that the other two teams have for this? I know that by what you tell me, the SHA-3 Coalition and the ETC Cooperative and Hyperledger Besu are on board, and I'm sure that they support it. If everything goes well and it's tested and nothing breaks, they would support it in the long term. How do you see IOHK with Mantis and ETC Labs with Core Geth?
Yes, so ETC Co-op is 100% on board. For the IOHK, they maintain the Mantis client, which is coded in Scala. And the primary idea behind the Mantis client is that they want to create as few lines of code as possible. So that team, and I'm in contact with them, are extremely interested in this project, and it's officially on the roadmap for the client to adopt the SHA-3 algorithm. And the reason why it's such a good mix for them is because ETH-hash, the current algo, is so complicated to produce and code. Yeah. And we should get into that too, actually, why I think it's so much better. I'll answer that after. But it's so complicated in code, and it increases the weight of the program so much that when a lot of these node developer teams look at it, when they get to know it more, they'll see, oh my gosh, doing this switch will actually allow us to decrease the amount of lines of code that we have to maintain and make it far simpler for us. Because instead of having to code up this complicated ETH hash algorithm in code, you just get to call, and every programming language has it built in by default. You just call hash.sha3,
Okay,
and you put it in, and it just works.
Yeah, that's an incredible efficiency, I guess.
Huge efficiency gain, and that's actually something really worth talking about here. So a lot of people ask me, they're like, okay, well, aren't all the proof of work algorithms pretty much the same? Like, why does it matter that Keccak 256 is higher performance than Ethash? And there's a lot of reasons why it matters and why we should adopt the highest performance one. The first thing is because right now, when you're confirming the block history for the entire blockchain, every block, it takes 80 milliseconds to verify the Ethash proof of work. So right now, ETC is almost at 15 million blocks or 14 million blocks. That means that if you were starting from scratch, you're wasting 14 million times 80 milliseconds for every one of those blocks. When if you were using Keccak 256, it would be practically instant. You would be able to run millions of checks against the blocks within the time it takes to do like 10 checks with Ethash. And that's just simply because it's a standard algorithm. So a lot of like CPU manufacturers like Intel, AMD, all these guys have hard coded the algorithm into the very chip itself. So you get this super optimized system that is very efficient on power and speed. So you think about like one of the core areas that ETC is going to move in the future is Internet of Things, IoT. So like if my car wants to pay your car, how is it going to do that? When you're dealing with IoT, you want to have as high performance and as lightweight of a system as possible, because you have computers that are potentially running in like on a combine or, you know, on an airplane or something like that. And you don't want to be wasting efficiency on just the hashing algorithm. You want it to be as lightweight as possible. So that's a huge advantage of Keccak 256. The other one too is the safety. So because as we're moving more into this quantum age where we're starting to get bigger and bigger quantum computers, and and the value of these chains are starting to go higher and higher, you're going to have more determined attackers that are going to look at it. So the reason why I really like the security profile of Keccak 256 is that it went through 10 years of testing. Thoroughly mathematic testing to check theoretically if it can avoid attacks. So it's been determined to be quantum resistant. Another thing that it went through was they had teams that spent years trying to break it, and no one was able to break it. So that is a huge selling point. And it's actually, when it comes to running certain code for financial information, or maybe you're aware of this, but there's a lot of rules actually around. If I created an airplane, for example, I can't run an arbitrary hashing algorithm.
Whatever thing that you make up.
Yeah, I have to use, when there are lives on the line or a lot of money on the line, I have to use the standard, well-proven hashing algorithm. And currently, ETH and ETC does not follow that rule because we're using a non-standard algorithm called Ethash.
So basically, it is more efficient. It is a standard because all chips and software everywhere and programming languages have it integrated as a standard hashing algorithm. And because it's more efficient, it blocks to verify past blocks is going to be much faster. So that is going to, in a way, make it faster for new nodes entering the chain to sync with the chain. That's going to be
exactly. That's exactly it. And also it enables new use cases in new types of nodes. So there's a node called a fly client, which was developed by an engineer in the space called Zach Mitten. And what he said is that he got all the code set up for the fly client, but then when he tried to run it, he said it would take 8 hours to run the fly client to sync on a phone or on a small computer. And why? There was only one reason why, because Ethash was so heavy that it would take a long time to generate. there's so much complexity in Ethash that is totally unnecessary, and basically it kills a lot of use cases that people have for creating lightweight nodes because of all the weight that gets added on by just this one feature.
So SHA-3 would make it more efficient to sync, like I said before, but also it would make it more efficient for technologies like Fly Client or Nipple Pulse, I guess, and atomic swaps to interoperate with other chains, just because
Exactly,
of the thing that it's the standard and it's more efficient.
And smart contracts can verify the work on chain.
Yeah, that's what I was going to say. So for dApp developers, it's also much more efficient.
Yeah, it's all round. It's just one of those things that it's a no-brainer once you really look into the details of why it is. But there is one debate, and that is the notion of ASIC resistance.
Yeah.
So the reason why Ethash, and I want to give credit to people on the other side who don't want to change. The reason why Ethash was designed to be so inefficient was not because of the cryptographic security or anything like that. It's inefficient because the idea is that it should be hard to build chips around it. And that will give little miners the chance to compete against the bigger miners. And I'm curious what you think about that, Donald. Like, I have my own opinions.
But I think that protecting the little guy, that philosophy is fictitious, because it doesn't matter that you prevent the big machines or the specialized machines. If you get one, if you have many little guys mining, eventually, because of normal physics and economics, some of those will not be little guys anymore, and they're going to have just more machines and billions of dollars in machines, and they're going to be big guys anyway, whether with ASICs or no ASICs, mining ETC or ETH, which is what's happening now. When you see the pie chart, the distribution of mining pools and miners in Ethereum, you already see that there's concentration there. It's not monopolic concentration, which is the security, the safety that we're looking for, but you always have in economics and in physics a situation where you start flat, and then eventually 20% get larger, and the 80% remain smaller. So the
Pareto.
The protection to the little guy is a myth. The other thing is that the myth is prevention, or to try to stop ASICs, not because Ethereum already has ASICs.
Yes, so that's the issue that I have with the Ethash is good for ASICs, or is ASIC resistant. The issue that I have is that there is no evidence that it is possible to create ASIC resistant algorithms. And there's many counterexamples to this. So Litecoin started out with ASIC resistant algorithm. Zcash started out with ASIC resistance algorithms. Monero started out with ASIC resistant algorithms, and Ethereum started out with ASIC resistant algorithms. And you know what the truth is? You can buy ASICs for all of them right now. And the only reason why there isn't more ASICs is not because of anything inherently in the science or in the math of it. It's just because there's not enough financial incentive to build those ASICs. So I've talked with engineers, very, very serious electrical engineers who are part of the SHA-3 Classic coalition. And they say, look, if ETH was 3 times the size and it was earning 3 times more per block, yeah, we would invest hundreds of millions of dollars into building ASICs. But there is none. So to me, this notion of ASIC resistance, it is just bad science. It's not true. There is no such thing as ASIC resistance. And Bitcoin, the very first one, was intelligent enough to not make that mistake of trying to artificially doctor the cryptography.
It is not true because of what you say, because of the science and physics. And it's also not true economically because and it goes against the philosophy of the protocol of Nakamoto consensus. Nakamoto consensus, what it seeks is for a group of or for a computing base to be competing to find the block, and this competition is what creates the big mass of computing power that protects the network. Not only protects the network because whoever wants to attack it in the current block needs to have this big computing power, but also because each block that accumulates in the future goes building this wall of protection that when a block
Yes.
that is a month old or 2 months old or a year old is practically impossible to reorganize because you need to reorganize all the blocks in front of it. So this economic design that Satoshi Nakamoto created, the whole like basic philosophy is for competition to be there, and if the players are not free to have the best machine with the best hashing mechanics or system and to outrun the other, then you are basically deteriorating the competitive advantage or the competitive like component of the algorithm.
And to add on to that, we've already had 6 51% reorgs in ETC with the status quo. So in my opinion, where we're currently at is unsustainable, and we have to change to something. But the question is do we continue the failed science behind this ASIC resistance, or do we really go forward with the new opportunities and we think 10, 15 years in the future? Because that's how I'm thinking about it. I'm thinking, how do we create ETC so that 15 years from now, it's the top smart contract platform in the world? The only way to get to that point where ETC can grow so massive that it can secure the world's wealth and financials is if it follows the best cryptography possible.
Yeah.
There's no exceptions there. There is no, oh, we're going to use weaker cryptography now so that these guys can get paid and that kind of thing. No, we have to use what is agreed upon to be the best.
It's definitely a point that has to be cleaned and corrected in a way, the original problem of hash, and then the new ETC hash that was created recently for ETC. It has to be clean, and
which I don't like I appreciate the work that ETC Hash has done protecting the network, because now, since it's slightly different, it means that if ETH miners want to attack, it's a little bit more difficult for them to do it, but it does not solve the underlying issue, because ETC Hash is just ETH hash, but with a few dials just changed to the side. It doesn't make it higher performance. It doesn't solve the issue of the fact that the same ETH miners can just load ETC software on their things and then attack. It doesn't change that at all. But if we adopt a very different algorithm and one that is everywhere else in the EVM, SHA-3, then we have a fundamentally completely different mining ecosystem where we no longer have to worry at all about ETH miners coming over and attacking.
Okay, very quickly, because we don't have much more time. So what was it? Well, did you ever talk, or what was the feedback of the core Geth team? Do you think that they're going to eventually test it on the testnet?
Yeah, I believe that they will, simply because all of the people, the core developers in the ecosystem are extremely intelligent, every single one of them. And every one of those developers knows deep down that the cryptography, the best cryptography, is the secret for ETC being able to succeed long into the future.
One of the arguments that they have, the core Geth developers have, and others in the Ethereum Classic ecosystem, is that we would be kicking away the miners, and that's not good, because they're part of the community. So what is your vision of how miners and also exchanges and node operators are taking this? Have you spoken to them?
Yeah.
Do they have a positive, negative view of this potential change?
Everybody that I have met in the space and talked with, who is a real individual in the space with lots of skin in the game, has all been supportive of this proposal. Because even so, first of all, I don't think that the miners will be kicked away, because this is a few years in advance, and you cannot predict what will happen with the market and the availability of new rigs and all of that stuff. And you can always mine on a GPU. The question is whether or not it will be profitable to do so, and that it's impossible to predict ahead of time. But I do believe that the majority of even big mining pools in the space are supportive of it because they know that it will increase the value of ETC much more in the long run. So if you have a mining pool that, let's say, has invested a lot and they can mine a lot of ETC between now and the activation point, and they know that when it activates, it'll increase the price maybe 15 or 20 times, then maybe they're not worried about it because they want to have that bump because they have so much ETC. So the calculus is very complicated, the economics behind everybody. But majority of people that I've talked to, and pretty much all of the named people that I know, are all supportive of it because they understand the mathematics.
Yeah, also that's another myth, that you kick away the miners. First, the miners go to wherever there is money to be made. And what I say is that Ethereum Classic is going to be, at current prices, is going to be giving rewards of $100 million a year. So if it changed, say in 3 months, 6 months to SHA-3, it's going to give whoever has prepared machines for that, which it could be a regular computer or an ASIC. It's going to, whatever group of miners starts mining ETC, they're going to get $100 million. So there is going to be someone who's going to invest to get those $100 million. That's the economics of how mining works.
And it's not the job of the developers to sort of plan the economy.
Exactly.
All I can do is say, this is the best cryptography possible, and as a developer, I like it because of XYZ. It's not my job to go in and say, oh, these guys should win and these guys should lose.
Exactly. It's not your job to be the developer, to be a central planner and to benefit the little guys and to save the world and all that. The world works in a certain way with physics and economics. And also, what I was going to say regarding the machines is that miners, they have to throw away 50% of the machines per year anyway, between 50 and 60% of the machines, because every 18 months to 24 months, the previous machine is obsolete. So this rotation means that they are used to having to compete, throw away the machine and get another machine, or add more machines, because if not, they're not going to get any rewards, because the hashing power of the network continues to grow, and as time passes by, the chip become more efficient anyway, or the computing base grows. So they have to always be changing dynamically and adapting. And it has happened before. Other chains have changed their algos, and miners just came back with whatever new machines they needed. So I think that everything points for Ethereum Classic to change to SHA-3. I mean, because of the algorithm itself, because it's a general standard in the world, because it's secure, because it's good for developers, it's good for interoperability, and it puts Ethereum Classic in a specific niche, as a leader in the niche.
That if we switch the algorithm and we adopt SHA-3, I believe that we will not have to make another hard fork for ETC, potentially for decades in the future. So it puts us in, we can still do more. There's other upgrades that everybody in the community has in mind, but I believe that as a first step, as solving just the 51% problem that we are having right now, we should go for what the best math and best cryptography we can do. And then once we have that stable platform, then we begin discussions about other complex topics like treasury and all of this stuff that, there are different opinions, but it's more philosophy and not really this computer science.
In terms of the core
science.
In terms of the core protocol and core components, SHA-3 would be a very stable future component. The reasons that you say, it wouldn't eliminate the 51% threat, because secure proof of work blockchains, the whole point is for them to be able to be, for others to attack it. No, that's a core security feature, because
history is subjective. That's the beauty of it. History is written by the victors. That's how reality actually works. So what is so interesting about this is that if you do have the majority of the network, the economics pushes you in a way that you want to serve the network the best you can, because you acquire more ETC. So Nakamoto consensus, in my opinion, is it will win the Nobel Prize.
I'm sure eventually. Okay, Alex, thank you very much for your time, and thank you very much for all of these explanations, and good luck with the SHA-3 Classic Coalition.
Thank you so much.
Bye-bye.
All right. Bye-bye.